Today's lesson is over parametric equations. You're used to seeing equations like this, where your variable is x, and you might do several things to x. So this is what you're used to. A parametric equation has an equation for x and an equation for y. It's not combined. And your variable for a parametric equation is t. So you'll have some function of t. So let's look at an example of a parametric equation. You have an x equation and a y equation, and your variable is t. So in this problem, we're going to eliminate the parameter. We're going to eliminate the variable t and get it back to something that we're used to seeing, an equation with y's and x's. So here, it tells me that x is t. So in this equation, where the t is, I can just put an x in its spot. So that's your equation. Y equals x squared minus 3. We eliminated the parameter t. This problem, I like to pick whichever one is simplest to solve. So I'm going to solve for t with this y equation. So I'm going to subtract 5 from both sides. So I get y minus 5 is equal to t. So now I'm going to substitute that into this problem. X equals 2 minus 3, and instead of t, I'm going to write y minus 5 because that's what t is equal to. Now we can solve. X equals 2 minus 3y plus 15. I'm solving for y. 2 plus 15 is 17, so I get x equals 17 minus 3y. I'm going to move this 17 to the other side, making it a minus 17. And then you can divide both sides by negative 3. So this is your answer. Y is equal to x minus 17 divided by negative 3. You could also write it as negative x over 3 plus 17 over 3. Same thing. But notice I eliminated the parameter. I no longer have t's. You have an equation that you're used to seeing, y equals x. So what does a parameter look like? A lot of times t stands for the variable time. So as time changes, your x value changes as well as your y value. So let's say, for example, time is at 0 seconds. To find x, you plug in 0 for time. So 2 minus 0, you get 2. For here, if time is 0, your y is 5. At 1 second, you'll plug in 1s for t's to get your x and y value. So you plug in a 1 here and a 1 here. So 2 minus 3, you get negative 1. And then 5 plus 1, you get 6 for y. At 2 seconds, you'll plug in a 2 here and a 2 here for t. So you get 2 minus 6, which is negative 4 for x. And for y, you get 7. Now you can graph the line that you get. So at time 0, you have the point 25. You're right here. Then at negative 1, you're at 6. And then at 2 seconds, you're at negative 4, 7. So your vector is going this direction. It's going this direction. You started at 2, 5, and you ended at negative 4, 7 after 2 seconds. All right, let's eliminate the parameter here. Whenever you have cosine and sine, you're going to use the trig identity. Cosine squared plus sine squared equals 1. So we're going to divide both sides by 4. So you get x over 4 equals cosine t. On this side, you're going to divide both sides by 4. So you get y divided by 4 is equal to sine t. Well, notice, if you square this side, you must square this side. If you square this side, you must square this side. Cosine squared plus sine squared is equal to 1. That means this plus this is also equal to 1. So your answer is x divided by 4 squared plus y divided by 4 squared equals 1. And notice my equation has only x's and y's, no more parameter, no more variable t. We eliminated the parameter t. And we use the trig identity for this. So now I'm going to find the parametrization for the curve. So I'm given 2 points. I have the point 3, negative 3, right here. And I have the point 5, 1, right here. I want to know what this line is. What is the line that goes from 3, negative 3 to 5, 1? What is this vector, this line? Okay, so first we can find the component. So what is this x distance? And what is this y distance? Well, since I plotted it on my graph, I can see that it went 2 spaces to the right, and it went 1, 2, 3, 4 spaces up. Okay, that's the component form of this vector. You can also do this by, your ending point is 5, so 5 minus your starting point 3 is 2, and then 1 minus your starting point, negative 3. 2 negatives become a plus sign, you get 4. Okay, so that is your component. Now, we want to know the line. And remember, parametric equations, you're going to have an x equation and a y equation. The way you do that is you put your initial points first. So your x, it started at 3. And to get to the next point, you went to the right 2 spaces. So I'll put plus 2t. For your y equation, start at your initial y value, which is negative 3. And from this point to get to this next point, you had to go up 4. Up 4. So you're going to put plus 4t. That is how you get the parametrization of the line. You always put your initial point right here, and then you put the change. So it changed it changed by 4 to get to the next point. Okay, either one works in my opinion. You can move the 1 over, and then you can divide by 2. So now you just plug it in here. Plug the t in, so you have x minus 1 over 2. And you can simplify that. If you distribute this 4 in, you get 4x minus 4, all divided by 2. So 4x divided by 2 is 2x, and negative 4 divided by 2 is negative 2. The other way you could have done it, you could have solved for t for this equation. So you would divide both sides by 4, so you get t is equal to y over 4. Plug that in to this equation. So you have x equals 1 plus 2, and your t is y over 4. And then do algebra to get y by itself. You'll get the same answer. So whichever way you want to do it. You can solve for t from this one or solve from t from this one. Is that okay? Okay. All right, let's do the next example that y'all did. You can square both sides to get rid of the square root and the squared. So you are left with x squared equals t plus 1. Then you subtract 1. So you get t is equal to x squared minus 1. So just plug that in for this t. So y equals t plus 7. And for t, you're plugging in x squared minus 1. So your final answer, make sure you combine your numbers. So you have x squared, negative 1 plus 6 is, negative 1 plus 7 is 6. So that's your equation. You have y equals something with no more t's. You eliminated the parameter t.